How do we know if our function is linear, quadratic, or exponential? So we have looked at these before for linear and exponential functions, if you think back. In a linear function, as x goes up by 1 each time, what's y doing? In this example, what's happening to the y as we move along? It's going up each time. How much is it going up by? By 4. So between each value, we're going up by 4 each time. So we call this the difference from each value of x. The y value is going up by 4. So the difference is 4 each time. So if we're adding the same thing every time, it's linear, right? Let's skip ahead to exponential. An exponential, what is happening to the y values as x goes up by 1? What's y doing each time?
Going up by half.
In this case, it's going... It is timesing by 2. So from 0.5 to 1, it does go up by 1/2. But from 1 to 2, does it go up by 1/2? No. So what's the same happening each time? We're multiplying by 2. So in an exponential function, we multiply by the same thing each time. So what do I think is going to happen in a quadratic function?
It's going to have the same on both ends. It's got to come up and down.
That's true. It has to come up and down. Does it look like we're multiplying by the same thing each time? No, because we start off at 3, then we're getting smaller, then we're getting bigger. So we're not multiplying by the same thing each time. Let's look at the difference. Let's look at what happens whenever we go from 3 to 0.75. So to find that difference, you could look at a number line and say, how do we get from 3 to 0.75? What do we have to do? But to plug it into your calculator, you could take 0.75 minus 3. So get out your calculators now. You're going to need them for today. What about from 0.75 to 0? Do we go up 2.25? No. But how do we get from 0.75 to 0? Are we adding or subtracting? We're subtracting. We're going from right to left. We're going backwards. And we have to subtract just 0.75, right, to get to 0? What about to get from 0 to 0.75? Now we're adding 0.75. What about from 0.75 to 3? Now we're adding 2.25. Okay? So, are we adding the same thing each time here? No, but do you see a pattern? You kind of see a pattern. So what we're going to look at now, we call this the first difference because it is the difference between each of those y values. Okay? But we can also calculate what we like to call the second difference. I'm abbreviating here. Okay? So the second difference is the difference between those first differences. So to find the second difference, we want to look at how do we get from negative 2.25 to negative 0.75. So to plug this in your calculator, type in minus or negative 0.75 minus negative 2.25. Plus, what'd you have? Plus 0.5? Plus 1.5?
Wait, so negative 7.5 minus 2.5?
Minus 2.25. Difference you get. I had one person say 1.5. Someone else agree? Does anyone else get plus 1.5 as their answer? You should. If you type into your calculator negative 0.75 minus a negative 2.25, because we're finding the difference as we go from negative 2.25 to negative 0.75. So to find that difference, we subtract. We start at the end and subtract the beginning to find the difference. All right. So look at it on a number line and think about, does that make sense if I got a positive or negative value? But I agree we are going to add 1.5 What about the difference between negative 0.75 and positive 0.75? What do we have to do there?
Negative 0.75 plus 2.25.
All right, plug it into your calculator. 0.75 minus a negative 0.75. So minus negative just plus. What's 0.75 plus 0.75? 1.5 again. Someone else got that same thing? Plus 1.5? I agree. We are adding 1.5 here. What do you think the difference is between positive 0.75 and positive 2.25? 1.5. So if we plug into our calculator, 2.25 minus 0.75, the difference there is 1.5. So we're adding 1.5 to get from 0.75 to 2.25. So our first difference isn't the same every time, but our second difference is the same every time. So if we have a quadratic function, the second difference is going to be the same each time. We're going to be adding or subtracting something each time. So how do you think that relates to a quadratic function? What in the equation of a quadratic function tells you that it's quadratic? The square, right? That degree of 2. What about in a linear? What's the degree of a linear function? Not in a linear. X is for exponential. What's the degree in a linear function? Just 1. So in a linear function, we're looking at the first difference. In a quadratic function, we're looking at the second difference, right? So we're going to look at some examples, and just based off what we know, we're going to be able to tell if they are linear, quadratic, or exponential.
Could a linear also be subtracting?
Yes, it could be adding or subtracting. Same with quadratic. You could be subtracting the same thing for the second difference each time. Alright, so number 1, does it look like we're multiplying by the same thing every time, or adding or subtracting? What does it look like we're multiplying by? Times 3. Do we in fact multiply by 3 each time? Yes, we do. So what type of function does this have to be? Exponential. As simple as that. Right? Number 2, looking at that, does it look like we're multiplying by the same thing each time? No, so we're going to have to look at the differences. So the difference from negative 6 to 3, what do I have to do to negative 6 to get to 3? Add 9. What about from 3 to 12? Oh, we have to add 9 again. And from 12 to 21, we also have to add 9. So our first difference is the same each time. So what kind of function is this one? Linear. Right? Number 3, does it look like we are multiplying by the same thing each time? We are subtracting by 2 every single time. From 7 to 5, we subtract 2. From 5 to 3, we subtract 2, 3 to 1, and 1 to negative 1. Each of those times we subtract 2. So what kind of function, Maddie Benz, is this one? It is a linear function. So the first difference is the same. Right? On number 4, does it look like we multiply by the same thing each time? The beginning, it's really hard to tell, right? With all those decimals. It'll give you a hint. Look at the second half of the table. We could try the first and second difference, but how do you get from 0.5 to 1? You could add 0.5 or times by 2, all right? What about from 0.25 to 0.5? All right, we could add 0.25 or we could times by 2, but it looks like we could maybe times by 2 each time. So double check with the first one. Is it also true for the first 2 that we can multiply by 2? Double check it in your calculator. Does it look like it works? Right, and so we could also check for the middle one. Right? But it is going to be true that every time we multiply by 2. So you don't always have to start by looking at the beginning of the table. If you have smaller, easier to work with values at the end, start up at the end and then go back and check with the beginning. But it is true we are multiplying by 2 each time. So, Nee, what kind of function does this one have to be? Exponential. Alrighty. Just two more. Number 5. Looking at that, does it look like we are multiplying by the same thing each time? It doesn't look like it, no. So let's try our differences. From 12 to 6, what do we have to do? Subtract 6. What about from 6 to 2? Subtract 4. And from 2 to 0, we have to subtract 2. Alright, so let's look now. Our first difference is not the same each time, so let's look at our second difference, the difference between the differences. So from -6 to -4, what do we have to do? Think about it on a number line for just a second. How do you get from -6 on a number line to -4 on a number line? Let's look at it. Here are a couple different things, right? So if here's 0, we have -6 and then -4. So we are moving to the right, so we are adding 2. What about from -4 to -2? We also add 2. So does it look like our second difference is the same? Yeah, so if our second difference is the same, what kind of function does this have to be? It has to be a quadratic function. No, but are we looking, so I agree, our first difference, if you look at all of our first differences, these are not all the same, right? But what about our second differences? It just goes away when you have it. Okay, so the second difference, we are adding 2 each time. If we look at our second difference, so if the second difference is the same each time, that makes it a quadratic function. But in order to find the second difference, do you have to know what the first differences are? Yeah, that's how you find the second difference. Alright, last one. Number 6. Does it look like we are multiplying by something each time? What do you guys think? I heard a couple different things. Maddie, what were you saying?
It's the same numbers as before, so it's either going to be like multiplied by 2 or divided by 2.
Oh, so you noticed that it's similar numbers, except for in number 4 they were decimals, and here they're whole numbers. So it looks like we're probably going to be multiplying in some way, right? So let's see. What do we multiply by each time as we go? Well, I'm going to give you a hint. You can look at the end of the table first. See if you come up with a pattern, and then see if it applies to the beginning of the table. So look at it on your own for just a couple seconds. Think about it. Look for a rule at the end and see if it applies also at the beginning. Right? If you think you have a rule, you can raise your hand. Winter? You could divide by 5 each time. Do you guys agree that you could divide by 5 each time?
No.
We could. From 625 to 125, we divide by 5. So we could divide by 5 each time. But do we like writing it as division here? No, we want to write it as multiplication. So how could we write dividing by 5 as a multiplication? Times what? What's another way to write dividing by 5?
0.05.
Jack? 1/5. Okay? Dividing by 5 is the same thing as writing times 1/5. So you can check that in your calculator as well. But look, 5 times 1/5, or 5 times 1/5, will that give you 1? Yeah, the 5's will cancel out. So we are going up by multiplying by 1/5 each time. So what kind of function does this have to be, Lexi?
Exponential.
Exponential.